So today we are going to do third part, which is Cotter. Okay, this Cotter part we are going to do, and once we finish this, we are going to assemble this in this Cotter joint assembly. So how to create this Cotter part? So first we are going to select this solid part. Then after that, once it comes in 3D environment, at that time we are going to select this protrusion command, not revolve protrusion, because it's a rectangular protrusion. You can see that it is rectangular protrusion. What we have done earlier in the earlier sessions, that was cylindrical in nature. So when it is cylindrical in nature, and if it is symmetric throughout its what's that around its axis, at that time we have to use this revolve protrusion command. Otherwise we have to go with this protrusion command only. Like if it is non-symmetric in each and every axis, like x y z axis, if it is having different dimensions, at that time we should be going with protrusion command. If it is different in x y z, if at least in xy or in yz or in xz, if it is having symmetric dimension, like in a plane, if it is having similar same dimension, at that time we can go for this revolved protrusion command. Otherwise, like either it should be symmetric in this particular plane, top plane or horizontal plane, or it should be symmetric in this vertical plane, or it should be symmetric in this right profile plane. So when it is non-symmetric, you can see that here it is 88 mm and here it is 34.5 mm, and the tapering, it's same thing, 1 is to 30 tapering is there. So it is for 88 mm it will be a little bit different, so we have to calculate it. Like for 90 mm it will be like 31.5 mm. If you can calculate it for 88 mm, we'll do that. Okay, then after that, in even uh, y-axis also, like z-axis and x-axis, it is different, and even in y-axis also it is 7.5 mm. So in each and every axis, like x, it may be y or it may be z. So in all the axes like z, x and y, it is having different dimensions. So when it is having different dimensions, at that time we should be going for this protrusion command only, and we have to create each and everything separately. So first initially I'm going to take this protrusion command, then after that I'm going to select this front plane, because as it is shown in the front view that this trapezoid is in front view, so I'm selecting this front plane. Okay, so once I select this front plane, I'm going to create one line which is equivalent to this particular dimension or particular trapezoid. So here the line's dimension is 80 mm. You can see that this is 80 mm. So we have to draw a line which is equivalent to 88 mm. Create a line which is equivalent to 88 mm, and above it is shown that it is 34.5. Here it is not shown, but here it is shown that it is 34.5. So I'm going to draw a line which is having 34.5 mm, and this line I'm going to move it. I'm going to select this entire line segments which I have created, and I'm going to use this alignment and also midpoint of this 34.5 mm and 88 mm intersection point I'm going to use it, and I'm going to keep it on this midpoint of this section or midpoint of these two planes. So I've kept it over here, and after this I'll be creating another line which should be equivalent to this dimension. So I don't know that dimension actually exactly. So for that, what I should calculate, I know that there is a taper of 1 is to 30. So for every 30-minute travel, for every 30 mm travel in vertical direction, there will be change in 1 mm in the horizontal dimension or horizontal distance. So here it is 88 mm. So 30 plus 30, then after that 28 mm. So 30 plus 30 means 2 mm is already reduced, which means 32.5. Then 28 mm means, if you calculate it, it will be 0.93332. Okay, so how we are going to calculate it? We know that it is 1 is to 30. Then if we calculate it for 88 mm, then 34.5 minus 1 divided by 30 into 88, if we calculate, then we are going to get, we'll be getting 31.567 mm. 31.566667 mm will be getting. So we'll be considering 31.567 mm. So here it is 34.5 mm and 88 mm, it will be 1 mm. Then once again for 30 mm it will be 1 mm, and for another 30 mm it will be 1 mm, and for 28 mm, the remaining 28 mm. So you can see that like 30 mm, for 30 mm travel, it became how much? It is reduced by 1 mm. So it is 33.5 over here. So 1 mm is reduced. Okay, 1 mm is reduced for 30 mm. And after that, once again for another 30 mm, it is reduced by 1 mm. So it became, instead of 33.5, it became 32.5 over here in this direction. Then remaining is how much? 30, 30 became 60, and this becomes 88 minus 60. That means there is 28 mm. So 28 mm, how we are going to calculate it? So it is 1 is to 30. That means 1 divided by 30 into 28. You will be getting your answer. So that will be nothing but it is 0.9333 like this. Okay, 9333. So this 0.933, if you are adding over here, so this will be our 0.933 dimension. So if I'm deducting this from 32.5, then here I'm going to get 31.567 mm dimension. So this will be our 31.567 mm dimension. So I'm going to draw a line which is equal to 31.567, sorry, 31.567 mm dimension. Then after that we are going to join this line. So all the things, now the Cotter is created, but here this Cotter is not fully converted because there is a round over here and there is a round over here. So that round we can create using this arc by 3 points command. So I'm selecting this corner, and I'm going to select this corner. And once I get this tangent over here, also you can create it around radius of 30 mm. We are going to keep. Okay, we'll be keeping a radius of 30 mm. As it is not given, you can give any dimension over here. You can give 30 mm, 25 mm, 50 mm, 60 mm, 70 mm, anything you can give, and this won't be playing that much important role. That's why you can give any dimension over here. As it should look like this, that's why I'm giving 30 mm dimension to that particular arc. So this is nothing but 30 mm dimension. This is 80 mm dimension. This is 34.5 mm dimension. This is 31.5 mm 57 dimension. Then we are having another arc over here from this point, arc by 3 points command, selecting this corner, and also I'm selecting this another corner, and here I'm going to mention once again 30 mm radius. Okay, 30 mm radius. But if we click on this return option, it will show that it is considered as sketch. I'll click on this thing return. So see here, more than two elements are joined at a single intersection point. So either I have to consider this as sketch, then it will be coming to what is that, a 3D environment, or I have to rectify this. So what are those extra lines? These lines we cannot consider it because inside the diagram we cannot create any line. So if that line is there, then that line will be considered as extra element. So for that purpose, I'm going to use this trim command, and I'm going to remove these lines. I'm removing this line. Okay, now I'm going to click on this return, but still this is not connected. It will show that. Okay, see here, profile is not closed. So the highlighted elements should be converted. So whenever you are getting any messages, then at that time you should see that and you have to rectify those things. Okay, here, as I know, as I've taught this earlier, so I'll be knowing this. Most of the time this will not be coming directly, so at that time you should see that message and you have to click on that message. Then once, see here, if I click on this return message, at that time the message will be coming, like it will be showing errors, just like the C programming, it was it will be showing the command error, right? The same error will be shown over here. Just have to click on that thing, then at that time it will be showing where is that error. See here, this is closed profile. It's considered as a corner. Here it is not closed profile. If you select this, there is no profile closure over here. So for that point, we have to create line from this line. Now it is closed. This is also have closed. This is also closed. So now we can click on this return option. Now if we click this return option, this will be created. Once again, we require, either it will be asking like whether it should be created in symmetric extent or in non-symmetric extent. Always we have to create it in symmetric extent. So when you are creating protrusion any part using protrusion command, at that time select this symmetric extent option. Okay, then this distance, the distance is given in this topic, which is 7.5 mm. Now we have created one quarter, but it is not at all having any round, but only the quarter we have created. Okay, we have created quarter. Now it asks whether it should be finished or not. So I am going to click on this finish option. So we have created a quarter which is not having any round edges, which is having sharp edges. This sharp edges has to be converted into round edges. So for that operation, I'm going to select round operation. Okay, I'm going to select round operation. And what should be the dimension of that round? It is equal to the half of this 7.5 mm. So it is 7.5 mm. If I'm seeing it from the top view, you can see that now it is looking like a, what is that? It is looking like a rectangle, but I want a elliptical shape, some kind of elliptical shape. So when I'm requiring elliptical shape, at that time I have to select all these longer edges, and the longer edges radius should be converted into half of this 7.5 mm. So it is totally 7.5 mm. If we divide it, then it will be equivalent to the radius of that arc. So it is nothing but 3.75, but I am going to state it as 7.5 divided by 2. So it will directly take it as 3.75. That I am going to change it as edge corner method. Okay, edge and corner method. So I will be selecting 3.75 mm, and after that I am just checking its preview. You can see that it is 3.75, it is 3.75. If we go to top view now, it will be looking like elliptical structure. You can see that the same like this one. Okay, same like the top view of this Cotter. Now I'm going to click on this finish option. Then I'll be going to this what is the diametric view option. Still it is not converted. Okay, it is not done perfectly. So here also we have to create another point over here. We have to create another section over here, but that section should be created somewhere at this tip of this edge. Okay, tip of this round edge. So for that purpose, what I'm going to do, I cannot create it directly. If I go over here, I want to create one what is that? There is a cut. You can see that there is a radius of 60 mm cut is there, and that has to be cut on this particular section only from this particular region, not entire Cotter, only at the tip of this Cotter. So over here also it should be done, and below also it should be done. So for that purpose, we have to create plane initially, because if I select this over here, I'll show that if I select top view, and if I perform cutout, if I select this, and if I perform, think that I'm going to create one round over here. Okay, think that somewhere like this I'm going to create it. It will be cutting this entire section, but I want the region only from this point to above region, only this much I require, but it will be cutting entire section, like entire Cotter will be selected. So to avoid that, what I'm going to do, I'll be selecting coincident, I'll be selecting parallel plane. So I'll be selecting this parallel plane, and I'm selecting this top plane, which is nothing but horizontal plane. I'll be selecting it, and I'll be placing it at the edge point of this tip of the Cotter. So at this point, I'm going to place it. To see whether it is perfectly placed or not, you can go with the front view option. So you can place it on this particular point. I'll be zooming that area also. Okay, you can see that I have to place it on this particular end point. Okay, at this particular midpoint, I'm going to place it. Okay, now I'll be going with the once again fit option, and I've created another plane. So top plane is there, and another parallel plane is created along with this, which is parallel to this horizontal plane. Now I am going to perform my action, which will be on this profile plane. So I'll be selecting cutout option. Okay, I'm going to select this plane 4. Now we know that the radius of that cutout should be 60. So I'll be creating one circle which is equivalent to 60. Sorry, radius should be 60. But we don't know the distance. We know that it should be placed over in this axis only, because you can see that at the axis of this line only it is placed, but we don't know exactly where it should be kept. So I'm going to keep it somewhere here. And also they have given that the distance between, you can see that. Okay, I will clear the diagram and I'll zoom this. You can see that from the axis it is some at some distance, this tip of this 60 mm circle, which is nothing but this tip of the or circumference of this 60 mm circle, it is at a distance of some dimension from the axis line of this particular quarter. So from here it is at a distance, but we don't know that, but it is at a distance of 2.5 mm. So here also it is cutting, one circle is cutting, another way also another circle is cutting. The distance between those two points, like circumference of those two circles, will be 2.5. So if I am selecting it from this particular region from here to here, it will be half of that 2.5. So it will be 1.25 mm. So total is 2.5. So this half section will be how much? It will be 1.25. It is half of 2.5. So now what I'm going to select, I'll be selecting this dimension, and I know that from here to this circumference of the point, it is how much? It is 60 mm, right? It is 60 mm. And also here to another point, so from here to this point it is 1.25. So I'm going to draw a line from this midpoint which is equivalent to length, which is 2.5 divided by 2 plus, which is about 1.25 plus the radius, which is nothing but 60 mm. So I'll be placing that 61.5 mm, 25 mm over here on this line. And after that I'm going to select this circle and I'm going to move it from the center of the circle to at that end point. Okay, at that end point. Now you can delete that 61.5 mm dimension. Okay, this 61 should be deleted actually, because it is considered as sketch otherwise. So I have to delete that, but this is the dimension. You should be knowing that this is the dimension, 61.25 mm. Now if I select this circumference point and with this line dimension, it will be 16 mm. And if I select this point, it is 1.25 mm. Which is 1.25 mm and this is 120 mm. It means radius is 60 and diameter is 120 mm. Then I'm going to click on this return option. Now it will be asking whether you want to cut it inside or you want to cut it outside. So it depends, like I'll be going with this isometric view and you can see that I want it till this point. So I'm selecting top view, sorry, front view, and I'm going to cut it till this particular region. Okay. Now I'm going to click on this finish option. Now if I go to diametric section, if I rotate it like this, you can see that there is a cut over here. This is a cut which is happened over here. The same thing I want to create in all other region. Here also I want to do it and here also I want to do it and in each and every plane I want to do it. So for that purpose what I'm going to do, I'll be selecting, there is a option called mirror option. I'll be selecting this cutout feature. Okay, and after that see here there is two options like mirror copy fast and mirror copy smart feature. Always select mirror copy smart feature because it will adjust all the geometry and also it will retain most of the parts. So for that purpose you have to select this mirror copy smart option. So I'll be selecting this mirror copy feature smart option. Then after that I'm going to click on this copy feature, accept. But it will ask on which plane you want it. So I'll be selecting this front plane. So once I select this front plane, this will be created over here. The same thing you can once again mirror it. Okay, you can mirror it smart plane, then select this top plane. It will be created and this mirror to, sorry, finish. Select this mirror to, once again move for mirror copy option, smart, and after that select once again front plane because you want to create it on that side. So we'll be selecting the axis where you want that mirroring should be happening. So this is nothing but front plane because it is having symmetry. So I'm going to select front view, it will be created. Then after that you have to click on this finish option. So if I go in each and every direction, that cutout is happened. You can see that this cutout is happened over here. Okay, now it is happened. Now if I will be selecting it diametric mode, then after that I'm going to click on, what is this, file properties. Okay, and here I'm going to write title as Cotter. Okay, and author is, you can use your initial. I'm going to use my initial, so I will be clicking on this. Okay, so it is saved as Cotter, and also the material should be assigned. So the material which is for the Cotter is steel. So directly go to tools, go to material table, and after that select the material from this particular library. So here it is stainless steel is there and also steel is there. Select this steel, then click on this to apply to model. Okay, click on this to apply on the model, or you can write it as steel only, capital letters. You can add it to library and apply to model. Okay, so once you apply to model, the color of this material will be changed into a little bit bluish in nature. So you can use this material over here. Now I'll be saving this in Cotter joint, telling it as part 3 Cotter. Okay, save it as hope all of you understood this concept. Now, if anybody is having any doubt regarding anything, you can ask me. Okay, I'll be giving you access to unmute yourself. You can unmute yourself and you can ask any doubt you are having. Anybody is having any doubt regarding this? Siddhant Patil, change your name. Okay, Siddhant Patil, change your username. The username should be your USN first in capital letters. Then after that, your full name. The same applies to 2KL19CH031 also. Otherwise, I'll be considering you as absent. I'll remove you now within 5 minutes. Then after that, I'm going to consider you as absent. Even Tanish Patil, I've told that it should be 2KL19CH040. Then after that, there should not be any like hyphen, or it should not be, there should not be any underscore. Only space should be there. Keep it. Then after that, you write your full name. 2KL19CH031. Siddhant Patil. Anybody is having any doubt regarding anything? I'll be reviewing you Tanish Patil and Siddhant Patil, and even who else? 2KL It was 39, I guess. Supritvi, right? Supritvi, you keep your number in that manner only. Siddhant Patil, change your name. Change your username.
So, so can we get a recorded video of this?
Where you want to keep it? Like I can upload it in any Google Drive. If your chemical engineering department is having some drive, then I can send it there.
Okay, sir.
I'll ask once Bhima Pasar or I'll ask Ranjan Naik here. I'll send it there. Okay.
Okay, sir.
I'll ask them. Otherwise, I'll at last I've shared that what is that solid software, right? In similar way, I'm going to send it later, but I'll finish all the assembly drawings. Then I'll be sending that, sending these videos, because it will be requiring some how much, like 500 MB, what is that, memory. So I can't afford that much more memory in a single day. So whenever I'm not having class at that time, I'll be uploading it. Okay.
Okay, sir.
Okay. If anybody is having any
Sir,
doubt regarding this, you can ask me. Otherwise, you can put your attendance in the chat box. Better you put one thing. Okay, all of you do one thing. I'll assign you number. That will be easy. Like instead of putting all this USN, if you click on this roll number, once that if it is assigned in the continue, then I'll be taking attendance in continue only. Till that time, you can put your USN. You can put your USN in the chat box. Put your USN as your attendance. For Siddhant Patil, I'm not going to consider your attendance. Okay, I'll be removing him. And don't write your name and all the things. Okay, if you have understood this, then you can leave. Mohammad Shoaib Sheikh. Okay. Don't keep all those spaces, okay, in between. And Mohammad Musab, because this number only will be coming in my chat box. So seeing that, I can directly put that attendance very easily. Otherwise, what happens if you are putting this attendance in some other format, then it will not be easy for me. So that's why I want this in order only or in format. Now you put, all of you put your attendance in the chat box, and your attendance will be based upon what you have placed in or what you have put in the chat box only. If you use these parts and assemble it, then it will be better. But for part modeling, you require all the practice for this parts, or all three parts, like quarter, sleeve, and rod end. So if you do that, then only it will be better. If you do it and if you practice assembly, then it is better. But only for practicing session, you can use the parts which are shared by me. Okay, I'm going to share these parts in the link, in the Google Drive link. If anybody is having any doubt regarding anything, you can ask me. Otherwise, I'll end the meeting here. Okay. All of you put your US in the chat box. Then after that, you can leave. Shreya Kamble and Sandeep Ayode and who is that? Mamata Sneha Hubballi. Don't put your name in the chat box. You already typed your name and USN in your username. So when you are putting your message, directly it will be coming, your USN will be coming, then after that your name will be coming. So you just have to put a message to show your presence. So even if you put present also, it's okay, but preferably you put your USN only. Don't put something else. And once it is done, then leave the meeting. Okay, leave the meeting so that I can stop the meeting and end the meeting for all.